let's see how this goes. I'm very curious to see what this is about. This is from the New York Times. Get ready for the new and improved second. Now, I'm unprimed. I don't know anything about this. Scientists are preparing to redefine the fundamental unit of time. It won't get any longer or shorter, but it will be more precise and a whole lot more powerful. So it's going to be more precise without changing. Now this is fascinating. Modern civilization, it is said, would be impossible without measurement. And measurement would be pointless if we weren't all using the same units. You know, I'm just pro-metric. Just throwing that out there, pro-metric. For nearly 150 years, the world's metrologists have agreed on strict definitions for units of measurement throughout the International Bureau of Weights and Measures, known by its French acronym BIPM. BIPM, and based outside Paris. BIPM! Nowadays, the Bureau regulates the 7 base units that govern time, length, mass, electrical current, temperature, and the intensity of light and the amount of a substance. Together, these units are the language of science, technology, and commerce. This motherfucker in chat, Andrew Kohler. Kevlin is better than Celsius. First of all, fucking Kevlin. What? Second of all, I call it centigrade, motherfucker. Centigrade's way cooler. Let's be real. BIPM! Scientists are constantly refining these standards. In 2018, they approved new definitions for the kilogram mass, ampere current, Kelvin, not to be confused with Kevlin, as Andrew Kohler in the chat is very interested in, and mole, amount of a substance. Now, with the exception of the mole, all of the standards are subservient to one, time. The meter, for example, is defined as the distance light travels in a vacuum during 1 of a second. Likewise, the new definition of kilogram rests on the second in a manner too complicated to explain in fewer than several paragraphs. All the units now are not autonomous units, but they are all depending on the second, said Noel C. Demarque, a physicist and president of BIPM's Consultative Committee for Time and Frequency. We're getting into some complex science here. I'm learning a lot. That means that conceptually, if clumsily, you could express other units such as weight or length in seconds. You go to the grocery store, I say, I would like not 1 kilogram of potatoes, but an amount of seconds of potatoes? What on earth? What on earth? Yet now, for the first time in more than half a century, scientists are in the throes of changing the definition of the second, because a new generation of clocks is capable of measuring it more precisely. Whoa, here we go. In June, metrologists with the BIPM have a final list of criteria that must be met to set the new definition. Dr. Demarque said he expected that most would be fulfilled by 2026, and that formal approval would happen by 2030. It must be done carefully. The architecture of global measurement depends on the second. So when the unit's definition changes, its duration must not. It's like a once in every 50-year thing, said Elizabeth A. Donnelly, chief of the Time and Frequency Division at the National Institute of Standards and Technology, NIST, in Boulder, Colorado. She is on the BIPM's International Consultative Committee with Dr. Demarque. And it's also a big deal. There you go. So anyway, they're changing the second. Once humans told time by looking at the heavens, but since 1967, meteorologists have defined time instead by measuring what's going on inside an atom. Clocking, as it were, the eternal heartbeat of the universe. Oh shit, here we go. Here we go. Here we go. Here we go. We're going in. Look at these guys. They went in, and now we're going deeper in. We're going inside the atoms. We're zooming in. All right. But time still has its roots and even its nomenclature in astronomical timekeeping. Originally, it was based on the path of the Earth in its daily spin. Day to night and back again. Eventually, ancient Egyptian astronomers who used the duodecimal counting system, based on 12, divided the day and night into 12 hours each, giving us 24 hours in the day. Those hours varied in length. Depending on where Earth was in its orbit around the sun a little more than 2,000 years ago, Greek astronomers who needed fixed hours to calculate things like the movement of the moon developed the revolutionary idea that a single day ought to be divided into 24 hours of the same length. Pip 'em! The same astronomical thinking led to the... Okay, so yeah, we got the little history lesson, which I do like. I do appreciate the history lesson. But let's, Metrologists turn to the far more predictable movement of atomic particles. Atoms never wear out or slow down. Their properties do not change over time. They are perfect timepieces. By the middle of the 20th century, scientists had coaxed atoms of cesium-133 into divulging their secret inner ticks. Cesium, a silvery gold metal that is liquid at about room temperature, has heavy, slow atoms, which means they are relatively easy to track. Goddamn bip 'em. Scientists put cesium atoms in a vacuum and exposed them to the energy of microwaves. In the non-visible range of the electromagnetic field, the task was to figure out which wavelength of frequency would excite as many cesium atoms as possible into emitting a packet of light or photon. Photon. The photons were picked up by a detector and counted. Smia, I understand zero of this. All right, let me see if I get this. Okay. So we used to use like sundials and shit, right? Looking like, fucking Stonehenge and all that crap to measure time. Dumbass motherfuckers. They don't know it, right? So we're thinking, all right, so we got computers now. We got like these machines. Let's try to find like what is a second? We used to use clocks or whatever, to figure out seconds. Let's try to like actually figure out what a second is. So they're zooming in. They're zooming in. I understand that, right? So they get a certain kind of metal, right? And they just track the way that the atoms move inside of this metal, because apparently it's consistent, according to this. It's consistent enough that you can, like, kind of tie a second, to, an atomic reaction. So I guess, yeah, so they're not changing the second, right? Like, so the article, get ready for the new improved second. What this means, basically, is they're just going to get more details about what's happening over the span of a second. That's what it seems to be here. The redefinition is in the works because scientists have developed new instruments called optical atomic clocks. These operate on similar principles to cesium clocks, but I don't know how to pronounce it, so it could be cesium, I don't know. But measure atoms that have a much faster natural frequency resonance, or tick. Those frequencies are in the visible or optical range of the electromagnetic spectrum rather than the microwave range. Hence the name. Goddamn bip 'em! There are several species of optical clock, each counting the ticks of a different atom, or ion. Yttrium, strontium, mercury, aluminium, and more. So far, no species has emerged as the clear favorite for the upcoming redefinition. Optical clocks are very definitely not ready for prime time, said Judah Levine, a physicist at NIST's Time and Frequency Division. They are laboratory projects. Okay, so they're working on zooming in, finding out a new way to measure the second. That's interesting. Genuinely, I'm not, I'm not joking. That is interesting. But also, there you go. That's it. By 2030, we got a new second, and that'll do something.